Hello, everyone. Welcome to this edition of the WiRE Virtual Networking Meetup event. My name is Brittany, and I'm just going to start off really quickly with some housekeeping items about how these events work. For the first portion of this event, I'm going to go through some information about WiRE for those of you who might not already be familiar with us, and add in a couple of announcements as well. And then we're going to get into our feature presentation with our speaker, Lisa Barber, today. We are going to have a short question and answer session after Lisa's presentation, but while she's giving her talk, you can actually type in your questions into the chat at the very bottom of your screen there. Just scroll on down and hover, and it'll pop back up again if it isn't already there. And then we're actually going to end off with a networking conversations portion of this event. The chance to actually network and get to meet new people and make connections is a thing about the WiRE events that we really love, and it's something that we've always gotten positive feedback from. So when figuring out how to transition our events here to go virtually for in COVID COVID times, we try to figure out what is the best way we can still keep that, because we do really want to keep those networking conversation opportunities as a major point of our events. So I do want to point out as well, I sometimes get mixed up about this. When we get to those breakout rooms, is what they're called, for the networking conversations, you might have to look for this other separate pop-up window. Maybe it's behind your your current Zoom window or something, but you have to click join in there in order to then be sent over into your what we call a breakout room. And in there, you can unmute yourself. You can turn on your camera and actually have a conversation face to face with a few people who are there in your group, and get to know each other. And without any further ado, I'm going to tell you all a bit about WiRE. So WiRE, for those of you who aren't already familiar with us, we are a nonprofit, and our purpose is to advance the role and recognition of women in the broader energy sector. Our organization was launched and incorporated in 2013 in Toronto, and we work towards this purpose I explained through our programming, which we offer for professionals and students of all genders, such as our networking meetups, capacity building field trips, speed mentoring events, and we also organize bursaries for post-secondary students to be able to attend industry conferences. We also share stories from women leaders through our blog, and we run several Women of Distinction Awards in partnership with industry associations and their conferences here in Canada. WiRE is also currently in the process of launching our Indigenous Women in Leadership Award, and we're also started earlier this fall a campus student ambassadorship program. I do have to say about virtual events, this is really a new thing for us, and it is a COVID time specific adaptation for us. So those on-site events, unfortunately, we can't have them running because of because we can't maintain social distancing and have everybody safe. So for the meantime, we're doing our events as much as we can, doing them virtually. So where is WiRE? Since that initial 2013 launch, we've actually branched out with our chapters to bring events to the industry across Canada, from Vancouver to St. John's, and also most recently in the Yukon. And most recently, we've also been expanding internationally, now with chapters in Turkey, Jordan, Azerbaijan, Georgia, and the UAE. And of course, WiRE wouldn't be able to do what we do without the leadership of this amazing team here. Our executive board is made up of our president and CEO, Joanna Osawe, as well as executive board members Aisha Bukhari and Julia Cushing, who are bringing their backgrounds in energy, innovation, and the environment. And as for today, who we have here with us today, so Rupam Singh is here. Rupam, maybe if you want to give a little wave, and she's going to be speaking speaking as well, so you will hear from Rupam. And there's myself, Brittany Berry. The both of us are actually co-leads of the local chapter that's from Hamilton, Mississauga. So we cover Hamilton, Mississauga, and basically whatever is in between. So our speaker is also coming from that area today as well. We've connected with her. Additionally, since this summer, I have also taken up an additional role within WiRE as an advisory committee member, running the networking events subcommittee. So that's why you're going to be seeing me running a lot of these events. And actually, going forward, we're going to be having more events coming to you from our other chapters all across Canada. So if you're coming in today from, excuse me, if you're coming in today from a different part of the country, you might actually see somebody a bit closer to you in the coming months. So with the next few slides, I just want to share with you about some of the values and initiatives that we guide ourselves with. This one here is the idea of global, and that is think global and act local. An initiative that we support is the Equal by 30 initiative. This is a public commitment for concrete action towards equal pay, equal leadership, and equal opportunities for women in the clean energy sector by 2030, and ultimately aiming to close the gender gap. We are also a supporter of the Leadership Accord on Gender Diversity from Electricity Human Resources Canada, with our public commitment to promote the values of workplace diversity and inclusion. And EHRC is a really great partner of ours. So here I'd also like to recognize and give some huge thanks to our other partners and sponsors. We get amazing support from government partners, from our major sponsors, from the WiRE Gigawatt Club, from our additional sponsors in Canada, our industry and education partners, and from our international partners. And just really quickly, I'm gonna, you might want to take a quick screenshot of this one actually. Some of our upcoming events these are the next two that we have coming up here. Our President and CEO, Joanna Osawe, will be speaking at this webinar about women in energy, from energy and utilities. So you might want to take just a quick screenshot if you're interested, in order to get the link there. And as for the next virtual networking meetups, just like this one, our next one is coming from the Calgary chapter. And that's happening on November 5th. you can find out more about that event and about our next virtual networking meetups after that, and everything else we're doing, of course, at our website at womeninrenewableenergy.ca. And finally, I'd like to invite you to also share with us in social media. So all of our links are there. That's where you can find us on LinkedIn, Facebook, Instagram, and Twitter. And without any further ado, Rupam, if you're ready, I'd like to pass it over to you to introduce our guest speaker.
Thank you, Brittany, and hello, everybody. I am Rupam. It's my honor to introduce our guest speaker, Lisa Barber, who is the Director of Business Development at CEM Engineering. Lisa has had an interesting career as she's navigated through various roles in sales and business development. She started her career at DC International, where she spent nearly a decade in various roles. She helped clients identify ways to reduce engine emissions in the mining, construction, natural gas, and power industries. Her love for engines grew when she was very young, while she worked alongside her grandfather, rebuilding two-stroke and four-stroke high-performance engines. Her passion and knowledge strengthened when she competed as a sponsored athlete in numerous motocross races. Currently at CEM, Lisa leads clients through various gates of engineering and project development for combined heat and power generations, biomass, biogas boilers, district energy, and energy management projects. She helps clients refine capital costs in consideration to project contingencies. She also is the executive producer of CEM's podcast, Energy Radio. So if you're interested in learning about new technologies, I recommend you check this podcast out. Anyway, enough from me. Let's hear from Lisa.
Hello there, guys. Thanks, Rupam, for the introduction there, and certainly a very big thank you to Brittany, Rupam, and the rest of WiRE for inviting me on today. Of course, in normal times, I would be sitting in front of you guys, and so it's a bit of a shame that we can't do that today, but anyways, hopefully the COVID situation will be beyond us shortly, and we'll kind of be moving over to those types of events in the future. Okay, Brittany, so you can advance the slide. All right, so I'm here today to talk to you about post-carbon solutions, which, some people talk about GHG emissions or greenhouse gas emissions. Some people refer to that as CO2 emissions. What I want to do as part of this presentation is sort of introduce to you some of the various carbon pricing schemes that are taking place across Canada. You'll notice that that's quite different depending on the type or on the province that you might be in, or that the facility is part of. And then I'll talk to you about a variety of different solutions to reduce those greenhouse gas emissions. When I initially came up with the topic, I was sort of struggling because this is just a very small handful of technologies that realistically could be deployed to attack GHG emissions or CO2 emissions. But I wanted to focus on these more specifically because I do have the most experience with these. So I will review distributed energy resources, compressed air energy storage, combined heat and power, microgrids, woody biomass, renewable natural gas, and hydrogen. And then we'll talk a little bit about some of the existing post-carbon projects out there that I hope you guys will find interesting. And then just to kind of finish it off, some ways to reduce your carbon footprint. Okay, next slide there, Brittany. And sorry, next one again. Perfect, thank you. Okay, so this particular slide talks a lot about the different carbon pricing that the various provinces are being exposed to across Canada. And as you can see, it differs quite a bit, province to province. Some people are part of this federal backstop program. Some people have established their own pricing system, and then some people are part of this OPPS. So there's a number of different ways that people are impacted by carbon tax or by carbon pricing, which of course, fits directly into the economics of a project. But for the purposes of this discussion, what I also wanted to do was sort of reference, what Ontario's segment looks like in terms of a power generation perspective, and how that might relate to other provinces, because the types of solutions that I'm going to be talking about today will directly impact how much carbon reduction or intensity you might be looking to reduce depending on the type of province that you're in. So if we were to compare, for example, or look at Ontario's electricity mix, you know, about 29% is created by natural gas fire generation, 34% is nuclear, solar at 1%, biofuel at 1%, wind at 12%, hydro at 23%. The hydro and the nuclear is mainly there to support our baseload electricity requirements. And then the gas fire generation is there to really support our peak load, with wind and solar sort of filling in some of the gaps there. But that is important for us to keep in mind, because when the nuclear or the hydro, which are mainly the kind of carbon-free type of technologies, are running, you know, you can argue that some of these technologies that I'm here to present to you today may have more or less of an impact in terms of what that carbon reduction might look like. However, when we're also looking at when those peaker plants might come on that are primarily natural gas fired, those peakers are typically coming on when it's very hot or very cold outside, and therefore there might be some further emission reductions that could be noted there. If you compare the province of Ontario, which, as you can see, is still fairly green in comparison with a province like Alberta, for example, which is predominantly still coal-based, although they are transitioning to cleaner fuels. If we start to look at even, you know, fossil fuels such as natural gas being used there, and with certain technologies, we're still reducing the carbon quite significantly. So I'll talk about a mixture of those technologies today, and how some of those will impact you differently depending on the province that you're involved in. Next slide there, Brittany. Okay, so the current debate is really very simple. Many people are questioning, do we electrify everything, or do we look at using the current natural gas infrastructure and injecting different types of fuels such as renewable natural gas or hydrogen into that mix, so that we can reduce perhaps the capital cost intensity that some of these facilities might have to go through. You can imagine that a number of customers who are involved in the C&I space, you know, have very large boilers or furnaces that are natural gas fired. Would be a lot harder to transition over to electrifying that completely. We're also looking at adding additional electricity load as time, you know, as the future progresses and we start to look more at driving, you know, cars that are fueled or propelled by energy storage solutions. So, you know, our demand is also going to change in terms of what that looks like throughout the day. And certainly from a overall capacity perspective, that will also be increasing. So I'd like to think that, you know, there's going to be a bit of a combination of both. Some people are pretty strong opinionated here, and some people say there's no room for the natural gas pipeline, despite the fact that it, you know, does currently or is built out and can support many of our needs if we're using renewable fuels. And other people think that it's a great opportunity to kind of use a mixture of different types of technologies to achieve essentially the same type of reductions or overall goals for Canada. Next slide, Brittany. So the first technology I want to talk to you about today is distributed energy resources, otherwise known as DERs. So a DER, from a definition perspective, really includes solar panels, combined heat and power plants, electricity storage, small natural gas fuel generators, electric vehicles, controllable loads, such as, you know, household thermostats, for example, you know, in simple terms, HVAC systems and electric water heaters. The definition is pretty broad, but the idea is really pretty simple, and that is to put power or secure power from a local perspective and decrease some of the additional costs to build out power in the area. One of the more recent programs that pilot programs has been introduced is the York Region Non-Wires alternative. We'll see how successful you know, that is, but that's certainly something that the ISO is looking into. And I think that realistically we'll be looking at more projects like this, you know, in the future to support not just the grid, but also keep, you know, reduce GHG emissions. And I say that because many of you might know that, at least in Ontario, we're looking to refurbish many of our nuclear plants. So as those nuclear plants are being refurbished, you know, the big question is, where are we going to get the power that we otherwise have and need to support, you know, basically, you know, everybody who's out there who requires power today. Some people are suggesting that distributed energy resources is part of the answer to that. And again, there could be a mix of renewable and otherwise current fossil fuel-based technologies introduced there. But keep an eye on this space, because I think that you know, DERs do have a place to stay. And certainly if you look at Europe, these, you know, DERs, although perhaps used or defined differently over there, are used quite a bit. Brittany, next slide. Compressed air energy storage is perhaps a pretty or an easier technology to understand, in the sense that what we're doing is we're taking electricity generated off peak. So in the case here, I don't think you guys can see my mouse, but essentially to the left-hand side of the screen, you're looking at you know, wind-fired generation that is basically powering a motor that's in turn powering a compressor, an air compressor, and forcing air into a depleted gas reservoir. So we have a number of these, of course, across Canada, certainly within Ontario, and perhaps, you know, a number of more of them in the province of Alberta, where we could store that compressed air and basically use it for peak electricity requirements. So essentially, you store the air in the depleted gas reservoir for a period of time, and then you use it during a peak period. It goes through a pressure air turbine, and then through the generator that's, of course, generating the electricity, and that's how you're using you know, that form of energy. So it's a pretty interesting technology. It's starting to get a lot of making a lot of headway across Canada with different suppliers, and certainly one to be keeping an eye out for as well. Next slide, Brittany. Okay, combined heat and power. Some people, you know, don't necessarily understand what combined heat and power means, but essentially the general definition is you're taking one fuel source and then you're getting two useful forms of energy out of that. So in the case of the diagram here, you have fuel gas, or natural gas most commonly, injected into the engine, used to burn in the combustion chamber of the engine. That engine is then powering a generator, which is producing electricity. And then you're getting two useful forms of hot water, or it could be steam or chilled water, thermal oil, through the jacket water heat recovery on the engine and the exhaust heat recovery on the engine. There, of course, are, we'll call it renewable types of fuels that could be injected into the combustion chamber as well, which I'll cover off a little bit later in this presentation. But some people don't really understand how a fossil fuel combined heat and power system can actually decrease grid emissions. And of course, the answer to that really comes down to, from a provincial perspective, you know, where you're looking at putting the CHP system. So for example, you know, in Ontario, there's some debate, and, you know, perhaps there's not really a general consensus that's been reached on marginal emission factors in terms of what that means with on-site CHP and how that can impact or reduce grid emissions. But the picture is perhaps a little more clear in a province like Alberta, where again, it's predominantly coal in terms of the power generation mix. By installing a natural gas-fired combined heat and power plant behind the meter, you're basically reducing your coal-fired emissions or grid emissions by using natural gas instead. So combined heat and power is certainly something that, you know, there's a number of plants within Ontario that are using this technology. And of course, because you're using this engine for, you know, ideally 8,300 hours or more per year, it's really reducing the base load of the facility. So you are using this all year round, ideally. Next slide, Brittany. Okay, microgrids. So microgrids is really a combination of using different types of technologies and understanding how and when to use the technology. So in this particular case, we've got solar, we've got energy storage, we've got wind, we've got a dispatchable load, for example, with where maybe you can plug an electric car in and you can use some of that energy. You've got curtailment loads that you could have at you know, a commercial or residential high-rise building or a home. And CHP could certainly be included in this mix as well. Essentially, you're using various technologies and basically controlling those based on what the current prices of electricity are, or whether the sun is shining or the wind is blowing. And of course, in those instances where they are not, you need to rely on a different type of technology, like perhaps CHP, that will allow you to still sustain the type of energy load that's required for the site. So microgrids are a very big, they've come a long way in the sense of the controllers that are capable of controlling these various loads. We're seeing a lot of activity within the US market with microgrids, and it is starting to filter down into the Canadian market as well, and understanding what that could look like. And this could also be part of a DER, or distributed energy resource solution as well. Next slide, Brittany. Woody biomass. So this is a bit of a controversial technology, in the sense that some people don't really understand too much about it, or how it really is carbon neutral. But essentially what you're doing is you're taking firewood, wood pellets, or wood chips, lumber, and ideally from a sustainable source. So what sustainable meaning, you chop down that tree, but you're planting another tree in its place, and you're using that wood to put that through a biomass boiler. And the biomass boiler is basically producing heat. And in the case of it being kind of part of a combined heat and power solution, it's also using that heat is going through an organic Rankine cycle, or ORC, to generate electricity. So again, similar to the fossil fueled CHP with an engine, CHP can also be, technically defined by using a biomass and ORC system, because you're using that single form of energy, such as wood. You're burning that and producing two useful forms of energy. Next slide. Renewable natural gas. I love this particular diagram. I actually stole this from AB's promotional material, because they do actually do a combination of upgrading and they do CHP. But this is a very interesting technology that's receiving a lot of attention, certainly within the US. There are certain provinces that are adapting or looking at biogas a little more seriously. So within Canada, that's typically BC, Ontario, and Quebec, which are all provinces that have had a number of successful biogas installations over the years. In the past, a lot of the time, people were using that biogas, which is basically created by, we'll call it feeding it with various types of waste streams. It could be organics. It could be cow manure, it could be pig manure, it could be corn husks, it could be sugarcane, but essentially it's a feedstock that can be broken down. Think of biogas actually like a form of a stomach, because that's essentially what's happening. The bacteria is starting to basically work at breaking that particular feedstock item down, and it's producing that biogas. And then the biogas typically goes to some form of a washing and dehumidification stage. And then you're injecting that into a combined heat and power system that's producing electricity and that waste heat. And the waste heat from that engine could be used to basically heat up the digester tank, which is typically required, but again, dependent on where you are geographically located. And you could be using some of that additional waste heat for decreasing natural gas costs by preheating or heating hot water, or creating steam or chilled water in the facility as well. More commonly, perhaps in the US, people are upgrading the biogas. So it is going through an activated carbon filter, and then through an upgrading system, and then it's getting injected into the system. So injected into the system would ideally mean that you're putting that into the national grid, or you are compressing that biomethane in the form of a kind of a compressed renewable natural gas, and transporting that to sites that might not have access, for example, to natural gas, and might be currently using diesel as a way to further decrease carbon emissions. Next slide. Hydrogen is receiving a lot of attention right now, and certainly a lot of attention in Western Alberta. or Western Canada rather, where people are looking to source or get hydrogen from some of the depleted oil and natural gas reserves or wells. But there are different types of hydrogen. There's brown hydrogen, there's gray hydrogen, there's blue hydrogen, there's green hydrogen. While in Alberta, the attention is really around gray and blue hydrogen. In Ontario, there is certainly some the need or where people are looking to install green hydrogen, which is essentially electrified, where you're using electrolysis to get that hydrogen. And then that could be used in a number of different ways. It can be used in a combined heat and power system. So in the case of combined heat and power, there are a number of engine OEMs that now have engines that can run on up to 100% hydrogen. It could be blended into existing natural gas on site to reduce your carbon footprint. It could be used to completely displace natural gas in many applications. There are some specific upgrades that might be required to the burners, for example, and boilers in order to do that, but it's definitely a possibility. It could be used in hydrogen-fueled cars. I know that Toyota and GM and actually Honda are all putting more attention on hydrogen cars today. There's been a big push for electrification and certainly for energy storage in the automotive sector. But people aren't forgetting about the hydrogen cars as well. And then of course it can be compressed or liquefied for transportation, although right now that's typically being done for short forms of transportation. And then it can also be injected into the natural gas distribution system, as Enbridge actually is currently doing in Markham. Next slide. So these are just a few interesting projects that hopefully some of you will find interesting as I did. So next slide, Brittany. So the ones perhaps most notably, at least in the Ontario marketplace, are probably projects that Enbridge is currently working on. So Hamilton Wastewater Treatment Plant, Toronto Disco Road Facility, Toronto Dufferin Facility, the gas utility voluntary RNG program. I'll speak about that a little bit towards the end in terms of how you can volunteer to actually source and use RNG as a residential consumer. Hydrogen power to gas facility in Markham. These are all really great projects. Definitely urge you to continue to pay attention to this because there's a lot of movement in this space. Next slide, Brittany. This is a kind of an interesting project that I came across maybe about a year ago actually, and one Saturday as I was reading the newspaper. And it just proved to me that, there are so many different ways that we could be finding energy and using that energy to successfully reduce our greenhouse gas emissions. So in this case, there are a number of people, obviously, thousands of people every year that visit Mount Everest. And I don't know that I would be ever one of those people that would ever look to climb it, but nonetheless, if it's of interest to you, great. But naturally, there's a lot of fecal waste that gets deposited on the mountain. And so this particular project looks at basically using that waste, putting it in the form of anaerobic digestion so that they're getting biogas yields and reducing the reliance on burning wood or dung for heating, and basically just curtail deforestation and reducing the limited wood resources that they have in the area. So I urge you to look into this project because there are some technical constraints in terms of just because of the weather that they have there in terms of heating that anaerobic digestion tank and making sure that it's getting the biogas yields that it's intended to. But it's a fairly interesting project if you want to look something up when you have some time. Next slide, Brittany. This is a great example of a CHP facility that's positioned at the Berlin airport. So they're getting their hydrogen from the electrolysis process, so that is known as green hydrogen. In this case, it's a 2G system, which is a packager which is using, I believe, the MAN engine for the purposes of burning that hydrogen. It is accepting 100% hydrogen, the specific engine. It's a fairly small engine of about 170 kilowatts, but it is one of 2G's actually first CHP systems that is using hydrogen. So there's many more that people are looking at just like this around the world. Next slide. This particular project I happen to know fairly well. It's called Bayview Flowers. It's within the Niagara region. It's a project that I know of well because my firm was actually involved in putting this whole project together. But basically, it consists of 2 anaerobic digesters at site. The feedstock has changed quite a bit over the years versus what's listed on this particular slide. I believe they're still using dairy manure, but they were actually using waste from Peller Estates and previously from Campbell Soup before it shut down. But those waste streams are essentially going into these 2 tanks that you see here at the top. So the anaerobic digestion tanks, the green, that is creating that biogas yield or the biomethane, and that is then being used in an on-site CHP system that's about 400, I think it's now 400 kilowatts. I think it was 250. And then instead of flaring any waste gas that's often part of a biogas facility, they're actually injecting that gas into this boiler that's been converted to basically run on that biogas. So there was a slight conversion that was required there. But it's also a very interesting project. And then they actually have solar on the roof as well. I'm not sure if they technically would have the ability of islanding the facility. If it did, then it would also meet the definition of a microgrid. Next slide, Brittany. So of course I had to put this in here because here we are talking about post-carbon solutions and ways to reduce GHG emissions, and for the most part we were talking about fairly large types of technologies that can reduce emissions at hospitals or universities or within the industrial space. And there are a number of those types of projects that are happening at even a much larger scale within municipalities as well. But when we look at reducing or finding ways to reduce our carbon footprint, we're typically looking at fuel, water, emissions, electricity, transport, offsets. Offsets, for example, you're taking a flight somewhere, you can actually, basically, we'll call it pay an offset, which would then go towards a green project. The funding would go towards a green project. Recycling and gas. So on the right hand side here, I've just grabbed a couple that I've taken from some other conferences that I've been part of. But one of them is eat less meat, specifically red meat. Cows do produce quite a bit of methane, so if you can reduce your consumption of red meat, that will certainly decrease your own carbon footprint. Use your organics bin. Most facilities or most municipalities now, at least major municipalities, do have an organics collection. So use that as much as you possibly can. Those are going towards great projects that Enbridge, the City of Toronto, and others are looking at, and using that gas to inject into the grid so that you and I and the facilities and companies we work for can buy that RNG. Use energy efficient light bulbs and shut the lights off when not in use. I think that one's pretty self-explanatory, but I see it all the time around my neighborhood where people have lights running all the time. Consider purchasing RNG from Enbridge, their voluntary renewable natural gas program. So this was actually more so, I think this was just approved, if I'm not mistaken, by the OEB. Something that you definitely should be looking into if you're looking to consume or pay for renewable natural gas to basically fuel your home. Consider taking public transit. Okay, many of us aren't maybe doing that now because we're working from home, in light of the COVID situation. But take public transportation when you can, or use your bike to work, bicycle to work. Use a smart thermostat. Again, most people are aware of this already, but when we leave our homes, well, not again so much now, but pre-COVID and hopefully post-COVID we'll be leaving. We leave our homes at 7, 8 o'clock, whatever it might be in the morning. That thermostat, if it's automatically programmed to come down, so that you're not using your air conditioner or your heating unnecessarily, is certainly going to reduce your GHG impact as well. And for people who are my age on this call, I think this has been ingrained into us since early days of school. But reduce, reuse, recycle. That's, I think, just an easy one. So I think that concludes my presentation. I had to kind of go through that pretty quickly because of timing. So hopefully everybody got a few little bit of, some nuggets. I think the next slide provides my contact information. Please feel free to reach out. I provide my cell phone number there. Feel free to reach out to me on my work email. I'm also on LinkedIn, so feel free to reach out there. And of course, feel free to visit my company's website, which is CEM Engineering at cemeng.ca. And lastly, I know Rupam mentioned it early in the conversation, but I'm also the executive director of Energy Radio, which is CEM's podcast. We talk a lot about different post-carbon solutions there with some, amazing people who are even, much smarter than I am. So I urge you to tune in and learn about all sorts of technologies through that media form as well. So thank you very much. Appreciate it, Rupam and Brittany. And if you guys have any questions, I'm happy to answer them.
Thank you, Lisa. This was quite fascinating. It was wonderful to see all these different solutions working together. We do have a question from our audience. Varsha Rangaswamy wants to know, what are your thoughts on carbon conversion through direct air capture technology, which is also being developed by Carbon Engineering in BC for a while?
I wish I could answer that one because I don't know too much about the technology, unfortunately. The thing about these post-carbon technologies is there's so many out there right now. And so what's so interesting about it is, here we are trying to figure out how we're actually going to get to meet our 2030 and 2050 goals. But I think really the solutions are in some ways out there. We just need to figure out what combination of the different technologies could be used to kind of, get us there and get us there obviously cost effectively. So yeah, I wish I could answer that question. I don't know too much about that technology. I'd almost have to look that one up.
So I think
I was just gonna say there, Rupam, sorry. I got a question in from Cora Carivo, and she was asking if she could unmute and ask a question. Cora, I'm going to say yes. So I'll give you a second there to unmute yourself. Are you ready?
Yep.
Great.
So,
go ahead.
Hi, Cora.
hi, just comment and question. I would have to say it's like I paid you. I work for Enbridge, so thank you. Like great things and shout outs and everything. Yeah, really great insight into the market. And I just want to follow up on the RNG program. Yeah, we were recently approved, and that'll be a $2 per month that you can opt to put on your bill to start buying RNG. And I think that will be probably, we're aiming for like first quarter, probably March, April timeframe that customers can start doing that. But yeah, I think kind of more to sort of like a question that everybody might be interested in. How, the business that you're in, kind of what kind of changes have you seen in I guess technologies or just the business that's coming through to you, and sort of how has maybe COVID impacted that, and kind of employment in the marketplace, and maybe just kind of like demographics in your own business, women, kind of any kind of changes you might have noticed over the course of the years in your career.
Yeah, that's good. I'm trying to figure out which one to answer first. Okay, so I'll talk maybe first about CEM. So CEM actually stands for Cogeneration and Energy Management. So as you can imagine, we deal a lot, or we're dealing a lot, well, to some extent still are in the cogeneration space. The business has certainly moved from a cogeneration perspective more from Ontario because of the elimination of the PSUI incentives, or Process System Upgrade Initiative, more so to Alberta. And again, just based on my earlier discussion, that's in part because of the carbon sensitivities in Ontario, some differences in terms of opinion on what the marginal emission factors look like here and how that can benefit the grid. Whereas the story is a lot more clear in Alberta, where it's mainly a coal, a coal market in terms of power generation. Of course, that's shifting very quickly. So, the changes that we're starting to see, we are paying a lot of attention to, we call it the post-carbon solutions. So we've always been involved in biogas and biomass. We're starting to add hydrogen to that. Interestingly enough, and this is probably of interest for you, Cora, just because of your position or your, the fact that you're part of Enbridge, we have a lot of industrial facilities coming to us saying, look, we have, X number of tons of this particular waste stream. And we'd like to find out, could we put this through an anaerobic digester and use that gas to displace some of our natural gas currently used on site? And if there's excess, inject that into the grid. And so that discussion is starting to take place. It's interestingly starting with more of the some of the larger organizations that have a more of a global footprint versus just a Canadian or North American footprint. So the story is it's there, it's happening. The economics are starting to improve. I'd love to be able to keep more of the gas if we could within Ontario, because some of these projects are talking about basically them being part of the Fortis BC program. So I'd like to see more of that. But yeah, the discussion's happening, and I think it's going in the right direction, and we're slowly going with that. So whether that means it's CHP, whether it means CEM from an engineering perspective is doing the upgrading with RNG going into the grid, or whether we're getting involved in biomass projects or other post-carbon projects, we have the ability of doing that. One of your other questions in terms of COVID, I have to say we've been pretty fortunate because we're an engineering firm. Typically, engineering goes through these high peaks and then these lower lulls, and we'd like to try and keep it steady, but that's not necessarily always the case. We were actually coming into a pretty big high with some of the projects that we were working on that, from an engineering perspective, we're going to take about a year to complete. So we're just nearing some of the tail end of that. So the initial onset or stages of COVID, it was certainly difficult, like for most businesses. We definitely saw that there was a lot less conversations that were being had. Now, I'm again the director of business development at CEM, so I'm part of business development calls almost on a daily. So there's certainly been an uptick there. And then I think your other question with regards to women in the workforce. It's been interesting. It's been interesting in the sense that I don't think CEM has seen any, we haven't really been hurt. We have a number of different women engineers and designers that are part of the team. The leadership team at CEM, like I hope most companies out there, was extremely supportive of women and just their families in general in terms of what that looked like from a childcare perspective. So that didn't maybe hurt us as much as maybe it did in some of the larger organizations where they weren't as supportive of that. But overall, it's been a pretty good experience for us. Of course, I'd always like to see more women in the energy market. That would be great to continue to see. I've been seeing just before COVID, a big uptick in women's attendance at conferences in the energy sector. So hopefully that will continue post-COVID as well. Hopefully that answers, I think, all of them.
That was great. Absolutely.
Thank you so much, Lisa. Thank you for your presentation. Thank you so much, everyone, for joining us today. Thank you, Rupam, for helping me out with moderating. And thank you so much to Lisa for your brilliant presentation for all of us today.
You're most welcome. Very nice to meet everybody.
Thank you.